Number 6. A limiting reactant, done by Antonio Grajales and Josh Tillett. Introduction. Limiting reactant is when there is a reaction with two or more reactants. Chemical reactions occur in a stoichiometric way, so not all reactant may be used up. It can be a one-to-one ratio or a one-to-many ratio. One reactant will be used up, which will end the reaction. This is called the limiting reactant. The other reactant will still have some remaining. In this reaction, we explore limiting reactant. There were two trials, one where sodium bicarbonate was limiting reactant, and the other was copper chloride. The reaction was between copper chloride and sodium bicarbonate, both of them being reactants and producing sodium chloride and copper bicarbonate. Color interpretation. The product being light blue-green shows that copper chloride is the limited reactant. The product being dark blue-green shows that sodium bicarbonate is the limited reactant. The pure solution original solution was blue-green, showing a balance between the two. Data tables. Table 1. Mixing solution of copper chloride and sodium bicarbonate. The copper chloride solution was observed to be blue. The sodium bicarbonate was observed to be colorless. After initial mixing of the two, we the mixture turned to a light blue, and after stirring, the blue liquid remained at top while it was colorless at the bottom. Table 2. Recorded observation of reaction mixture and product from the reaction. First, we'll start with trial 1. The mass of salt was 0.15 grams. The mass of the filter paper was 0.55, and the mass of the filter paper and precipitate was 0.74, giving us a mass of copper bicarbonate 0.19. In trial 2, the mixture of the salt was 0.4 grams, the filter paper was 0.5 grams, and the mass of filter paper and precipitate was 0.72, giving us 0.18 grams of copper bicarbonate. Table 3. Identification of limiting and excess reagents from the filtrate appearance. Observation for trial 1. The color filtrate was a blue hue. The limiting reactant, sodium bicarbonate. The excess reactant, copper chloride. Trial 2. The color filtrate was colorless. The limiting reactant, copper chloride, and the excess reactant, sodium bicarbonate. Table 4. Calculations for determining percentage composition of reaction mixture. This is the table mixtures as we will go over the calculations in the calculation sections. This is the continuation of table 4 that's showing more calculations for each trial.
In this experiment, we calculated the percentage composition of a mixture containing copper 2 chloride and sodium carbonate by analyzing the reaction that forms copper 2 carbonate as a precipitate. Using the balance equation, we know that 1 mole of each reactant is a 1-to-1 ratio to form 1 mole of copper 2 carbonate. The mass of copper 2 carbonate obtained from each trial was converted to moles by dividing the measured mass by its molar mass. In trial 1, 0.19 gram of copper 2 carbonate, gave 1.54 times 10 to the negative 3 mole, and in trial 2, 0.18 gram of copper 2 carbonate gave 1.46 times 10 to the negative 3 mole. Since the molar ratio is 1-to-1, the same number of moles of copper 2 chloride and sodium carbonate reacted. We then multiplied these moles values by their respective molar masses, which would be 1.34.45 grams per mole for copper 2 copper 2 chloride and 105.99 grams per mole for sodium carbonate. To find the mass of each that reacted in trial 1, we had 0.207 grams of copper 2 chloride, and 0.163 grams of sodium carbonate reacted, while in trial 2, 0.196 grams of copper 2 chlorate and 0.155 grams of sodium carbonate reacted. To determine the limited reactant, we both use the filtrate observed and the reaction stoichiometry. In trial 1, the filtrate showed a blue hue, indicating that there was leftover copper 2 plus ions from the copper 2 chlorate, meaning the copper 2 chlorate was in excess and the sodium carbonate was a limiting reactant. In trial 2, the filtrate was colorless, showing that all copper chloride reacted. So copper chloride was the limiting reactant and sodium carbonate was in excess. When we found the remaining mass of the excess reactant by subtracting the reacted mass from the initial mass in the mixture. Finally, the percent composition was calculated by dividing the mass of each component by the total mass of the salt mixture and multiplying by 100. In trial 1, the mixture was 9.04% copper 2 chloride and 39.28% sodium carbonate, while in trial 2 it was 49% copper chloride and 34.75 sodium carbonate. These results show how the limiting reagent controls the amount of copper 2 carbonate formed, and confirm the one-to-one stoichiometric relationship between copper 2 chloride and sodium carbonate in the reaction.
Analysis. Solubility is the ability of a substance, called a solute, to dissolve in another substance, called a solvent, to form a uniform mixture, the solution. The dielectric constant: how well a solvent can separate ion and dissolve in water. Limiting reagent is the substance in a chemical reaction that gets completely used up first and therefore determines how much product can be formed at the end of the reaction, even if more of the other reactant is available. Theoretical yield is the amount of product you should get if everything is done perfectly. This is calculated. A precipitate is a solid form and separates out of a liquid solution during a chemical reaction. Percent yield is the actual yield you get from an experiment. This is and reactivity is 2 sodium plus copper chloride aqueous give us a product of copper carbonate solid plus 2 sodium chloride aqueous plus carbon dioxide and water. It is a double displacement reaction. What color should be the filtrate if copper 2 chloride were the limiting reagent? The color should be a light blue-green. What color should it be if sodium bicarbonate was the limiting reagent? It should be a dark blue-green. Explain how you are able to predict the color of the filtrate for these two questions. I was able to predict the filtrate color because copper chloride is blue to blue-greenish, and with it being in excess, the filtrate or the product will be a more darker blue-green, while sodium bicarbonate is more to colorless or a light color. So with it being in excess, the filtrate will be a light color, which is the light blue-green. Based on these answers, what was the limiting reagent in each of the trials based on the color of the filtration in each of the two trials? Well, as we can see from the data table, in trial 1, The filtrate was dark blue-green, so the limiting reactant was sodium bicarbonate, and in trial 2, the color filtrate was light blue-green, so the limiting reactant was copper chloride. Did identification of the limiting reagent by color of the filtrate accurately predict yield of product in each case? If not, what might have caused detraction from this yield? Answer: yes. What was the percentage yield for this reaction? Do you think that this reaction has a high yield? Suggest at least one way that the yield might be improved. Answer: the percentage yield of trial 1 was 38.1%. The percentage yield of trial 2 was 39%. No, the reaction did not have a high yield. The yield could have been improved if the solution was poured into the burner filtration setup faster. It was left to settle for a while. The results of one student experimental results from this exercise show a percent yield of 115%, provide a plausible explanation other than gross errors in weighing for how this may occur. Answer: the product was not dried properly. Water was still present and it affected the weight. A student in a hurry poured the reaction mixture from the beaker very rapidly into the Buchner funnel, such that some of the mixture ran along the edge of the filter paper. What effect is this expected to have on the student's determination of percent yield? Explain. The percent yield is expected to be low because the student lost some product by it being sucked up by the filtration funnel. Conclusion: in conclusion, the percent yields were low. In trial 1, the limiting reagent was sodium bicarbonate, and in trial 2, it was copper chloride. The colors were found to be dark blue-green and light blue-green respectively. We obtained an average of 0.185 grams of copper chloride. Thank you for your time and attention. We greatly appreciate you accepting the late work too.